Hello, math students. Today we're going to be going over how to solve linear equations. So like with the other tutorials, we'll be going over the tutorial first, then going over the practice. I'll be going over all the practice questions and then going over the mastery test. And I won't be going over the mastery test questions, all of them in full, but I'll give you a hint on all of them. And you'll be offered 5 of the 20 questions that I'm going to go over. And you have to get 4 out of 5 correct on the mastery test. But with that, hopefully you're on the tutorial. This is solving linear equations tutorial. And you can go ahead and just move to page 5. That's where the lesson really starts. Go ahead and give these a try. But if you need help, I'm going to go over this. You should know how to do this from last time, but let's go ahead and do this anyway. Remember combining like terms. We want to combine these x's together. So in this first expression, there's a 12x and a negative 7x. So since they both have x, you just add or subtract their coefficients. So 12 minus 7 is 5x. And then 8 minus 10 is negative 2. When it comes to adding and subtracting positives and negatives, just always keep in mind that you take the sign of whatever you have more of. Okay, so in the case of 12 minus 7, you have more positives, so that's why 5x. But 8 minus 10, you have more negatives, so that's why it's a negative 2. Okay, again, just combining like terms with this second example. So 17/3 x minus 2/3 x. Don't be alarmed by the fractions. It's not a big deal in this case, because when it comes to adding and subtracting, you need to have the same denominator. We already have that. So you just subtract the numerator. So 17 minus 2, which is 15/3 x. And that equals just 5x, because you divide. 15 divided by 3 is 5. So we're going to have 5x. And now let's combine our constants. 17 minus 15 is plus 2. All right, next one, negative 12x plus 7x. Again, combining like terms. These are both x's. Negative 12 plus 7 is negative 5x. And then 8 minus 10 is negative 2. Here you have more negatives. This one, similarly with adding or subtracting fractions, you want to have the same denominator. We do in this case. So negative 9/2 x minus 1/2 x is negative 10/2 x. Keep in mind, these are both negative, so that's why they combine together. In other words, they more or less add. If they're different signs, one positive, one negative, they would subtract. Okay, so that gives us, dividing this out, gives us negative 5x, and then 9 minus 7 is 2, positive 2. So negative 5x plus 2. So just drag these tiles to the correct spots on this according to what we just did. Now, I want you to keep in mind that as we go through this, you should be writing down everything I write down, and you should be writing down everything I tell you to write down. That way you'll get the fullest understanding of what we're doing, and I guarantee it'll make a lot more sense if you just write what I write and try to understand what I'm saying. Okay, so here we've done ones like this before where we have to give the reason for each thing. So in this example, the first thing we would do, or first thing I would do, is combine together like terms. So I would do this positive 1/4 x minus 9/4 x. So combine those together, that's combining like terms. And you can see they did that here. They combined those together to get 2x. So whenever we're combining things together, we can call that combining like terms. Okay. What would be our next step? Well, I hope you can see we would use the addition property of equality, adding 7 to both sides of the equation to cancel out this minus 7. Then we combine like terms again. We would combine the -7 and 7. Those cancel. We'd also combine on the right side -15 plus 7, giving us -8. Here they're calling it simplification, but that's essentially the same as combining like terms. Next, we have -2x equals -8. So we're almost getting x by itself. We just need to get rid of this -2. Remember the -2 right up against the x, that means they're multiplied. So we're going to have to divide to cancel it using the division property of equality. We divide both sides of the equation by -2, giving us 4. We just need to simplify. Okay. All right. I hope that made sense. Ideally, you should try to do these on your own before I give you all the answer, but if you're not sure how to do it, don't worry about it. I'm going over it. Okay. Now we get to this activity section on page 16. So go ahead and just skip to page 16 and we'll go over it step by step. In this activity, you'll analyze a student's process of solving an equation and build and solve a linear equation from a model. Lily solved the equation 3x minus 10 equals -3x plus 8. The explanation of our process is shown. Select the text that shows an error in her process or justification of steps, if one exists. So we're going to click the error, basically. And it might be that there are no errors, so we click this one. So let's go and see what we would do first. Now, the one thing I want you to notice about this equation is it's a little bit different than what we've done before. And the main thing that makes it different is the fact that there's x's on both sides of the equal sign, right? So here's the equal sign. You have a 3x on the left and you have a -3x on the right. So we haven't done one like this yet, but it's not really that big of a deal. The one thing I want you to think of, though, is you want to get all your x's together on the same side of the equation before you do anything else. Generally, that'll be your first step when solving most equations, is you want to make sure whatever variable you're solving for, in this case, we're solving for x, you want them all together on the same side of the equation. So the fact that there's x's on both sides of the equation, we don't like that. So what we're going to do is we're going to use the addition property of equality to move all our x's to the same side. I'll show you what I mean. So I'm just going to rewrite the problem. And again, whatever I write, you should be writing. Okay. Now, what I would do first is I'm going to add 3x to both sides of this equation. Okay. What that does on the right side is it cancels out this -3x and this +3x, they cancel. But on the left side, we have 3x plus 3x, that's 6x. So in total on the left, we have 6x minus 10 equals, and then on the right, after these x's cancel, you have 8. Okay, and you could see Lily did that correctly, right? She did the addition property of equality and got 6x minus 10 equals 8. That's great. All right, what would be my next step? Well, my next step, I think, would be to add 10 to both sides of the equation. That would give us 6x equals 8 plus 10, which is 18. Again, we're adding something to both sides of the equation. So that's the addition property of equality again. So that's correct. And the result is 6x equals 18. That's correct. Now, what would be my next step in solving this? Well, I hope you can see that this 6 and the x are multiplied. So to cancel it, we would use division. Whatever we do to one side, we do to the other. X equals 3. So here we divided on both sides. That's the division property of equality. Notice she put subtraction property of equality. That's not correct. So that's where the mistake lies. Okay. Even though she got the right answer, she didn't give the correct justification in this case. All right, let's take a look at this question here. So we have this balance model. Whenever you see a balance, think of it as an equation, right? So there's like an equal sign between the left side of the balance and the right side of the balance. So if your scales are flat, like level, like this is flat, that means whatever's on the left side equals whatever's on the right side. Okay, so we can turn this into an equation that describes this scale. What would we call this left side? Well, I hope you can see there's 2 y's and then 3 1's. So 2y plus 3 constant, okay, equals, what about this right side? Well, how many y's are here? 4 y's, and there's a plus 2, so 2 singles. So this is the equation that's represented by these scales. Let's go ahead and put that equation in here. So you would just put it just like that. So it was 2y plus 3 equals 4y plus 2. Okay, and that's it. Now, assuming the weights are in kilograms, I'm on part B here. What is the mystery weight of y? Use the equation you created in part A to find the solution. So essentially, we're going to solve the equation that we just created. Solve the equation right here. Okay. So again, look, in this case, I've got y's on both sides of the equation. I don't like that. I like to have all my y's together on the same side. Now, which side should you have your y's on? It honestly doesn't matter. You can move all your y's to the left if you're more used to that, or you can move all your y's to the right. You should get the same answer either way. In this case, I'm going to show you just moving all the y's to the right. So what I would do is I would subtract this 2y on both sides of the equation. Now I will only have y's on this right side. See that? So on the left here, I've just got 3 and then equals. Over here, I've got 4y minus 2y. So that's 2y. And we still have a plus 2 here. My next step would be to get rid of this plus 2. And the way you would do that is you would subtract 2 on both sides of the equation. Okay. On the right here, we have 2y. After these 2's cancel, 3 minus 2 is 1. Okay, we almost got y by itself. All we need to do now is get rid of this 2. Remember, the 2 is right up against the y. That means they're multiplied. So to cancel it out, we're going to go ahead and divide by 2 on both sides of the equation, giving us that 1/2 equals y. So y equals 1/2 of a kilogram. Okay. Correct. You can see they followed the exact same steps here. Okay. Well, that's it for the tutorial. Now what we want to do is I want you to go to the practice. So your first question looks like this, and it's in the practice right here. So solving linear equations practice, and we're going to go over the practice and the mastery test. Okay, so your first question on the practice looks like this. Drag each step. Let me move my face here. Drag each step and justification to the correct location on the table. Each step and justification can be used more than once, but not all steps and justifications will be used. So here's, you're clicking and dragging these things in here. You could use each of these more than once, but not all of them will be used. So here we've got negative 2x equals 28 minus 6x. You can see here there's x's on both sides of the equation. Remember, we don't like that. We want to move all our x's to one side. So in this case, let's go ahead and move our x's to the left side. So we're going to add 6x to both sides. Add 6x to both sides. Negative 2x plus 6x is 4x. So yeah, when you're adding and subtracting, if there's one positive, one negative, they subtract. In this case, it stays positive because you have more positives, okay? Over here, this goes away. On the right, you still have 28. Okay, now let's look at our question here. So the first thing we did was we added 6x to both sides. That's good. So whenever we add to both sides, that's the addition property of equality. So this is going to go in this first blank here. Addition property of equality. Whenever you add to both sides, that's addition property of equality. Then we simplified and got 4x equals 28. So 4x equals 28 is going to go right here. Okay. All right, I'm going to change colors so that hopefully we get less confused. All right. The next step, hopefully you could see, we would divide by 4 on both sides of the equation to cancel this 4, leaving us with just x on the left. 28 divided by 4 is 7. So we divided on both sides, so that's the division property of equality. That would go here. And we need to show that division, so that would go, this one goes here, okay? Then we simplify and we have our answer. So our answer will go on the very last one. Hopefully it's not too confusing with all these lines and arrows, but yeah, that would go here. Okay. I think you could probably do that one on your own anyway, but all right. What is the justification for step 3 in this process? Okay, so we have some fractions. So I think what they did first was they subtracted 1/5 h to both sides. That gave us this. Then we add 15 over 2, 15 halves to both sides to get rid of this. Okay. Now, what would be the step here to go from here to here? Well, one thing you can do with fractions, and I kind of want to show this off a little bit. If you have a fraction multiplied by, in this case, a variable h equals 15 over 2. What you can do is you can, let me change colors. What you can do is multiply by the reciprocal of this fraction, and that'll cancel it. So notice 23 over 10, I'm multiplying by 10 over 23. This cancels completely. But then you'd have to multiply the other side of the equation by the same thing, 10 over 23 in this case. This will give us h by itself equals, and you get 75 over 23 after you reduce. So this would give you 15 times 10, which is 150. 2 times 23, which is 46. But this reduces down. You can divide both these by 2, giving us 75 over 23. Okay, so but basically they multiplied by 10/23 on both sides of the equation. So that's the multiplication property of equality. Okay. All right. Now here's another problem. It's got fractions in it. Okay. Now, one thing I want you to keep in mind is see how this fraction bar goes over the whole left side and then there's a 4 below it. That means this whole thing on top is divided by 4. So it's negative 3x minus 7, that whole thing divided by 4. So you could see what would be your first step? Well, to cancel out division, we could use multiplication. So we go ahead and multiply both sides by 4 in this case. And you can see they did that here. They multiplied the left and the right both by 4 to cancel out this, right? See, in the next step there, that cancels. 11 times 4 gives you the 44. That's where that comes from. So they simplified things, got there. then what would be your next step? I hope you can see you would add 7 to both sides of the equation. And indeed, that's what they do here, right? They added 7 to both sides of the equation. So what's the justification, or what's the reasoning here? Well, when you add to both sides of the equation, that's the addition property of equality. Okay. All right. This one's going to be a little more time consuming, but we want to select the equation that has the same solution. So first thing we need to do is find the solution of this equation. Okay, so let's go ahead and solve it. I'm just going to write it to the side here so I've got some room to work. And I suggest you copy it as well on a piece of paper. There's really no substitute for writing this down, physically writing it down on paper. You have to do that, honestly. Now, you can see I've got n on both sides of the equation. Hope you remember, I don't really like that. I want to move all my n's to the same side. So I'm going to use the addition property of equality to add 14n to both sides of the equal sign. This cancels this n. That way, you don't have any more n's over here on the right side. You just have this minus 5. Over here on the other side, though, negative 5n plus 14n, well, one positive, one negative, they actually subtract, right? I know it says plus, but these actually subtract each other. So that's going to give you 9n. In this case, positive because you have more positives. There's still a plus 31 here as well. Let's see, let's go with green. For my next step here, we're going to go and use the subtraction property of equality to cancel out this 31. So we're going to subtract 31 from both sides of the equation. This will give us 9n equals negative 5 minus 31 is negative 36. Here they're both negative, so they actually add together. Go ahead and divide both sides by 9 to get our variable n by itself. N is negative 4. Okay, so we have our answer, n is negative 4. So I need to figure out which of these has that same solution. So we're going to have to solve these guys until we find one that has the exact same answer. All right, so this might take a little bit of work, but let's go ahead and just, hopefully it's the first one. That way we don't have to do as much work, but we're going to have to work through these until we get the same answer, n equals negative 4. So let's go ahead and take this first one. It has fractions in it. And I'm going to show you a little trick you can do to help you get rid of fractions whenever you have an equation with a lot of fractions in it. So notice that the fraction, in this fraction, the denominator is 4. And then this fraction, the denominator is 2. Well, what you can do is you can multiply using the multiplication property of equality. You can multiply everything by the common denominator, and that gets rid of all the fractions in the equation. So in this case, I'm working with fourths and halves. So the common denominator, the lowest common denominator is 4. Okay, so we're going to multiply everything on both sides of this equation by 4. And let's see what that does for us. So first, let's work on this left side. So 4 times 11 over 4n. Here it's kind of like you're multiplying by 4 and then dividing by 4, right? So those cancel completely, leaving us with 11n. Then the 4 needs to go get multiplied by this 2 as well. So that's going to be plus 8. On the other side of the equation, this 4 gets distributed to both of these terms. 4 times negative 3 is negative 12. And then when we multiply this fraction times 4, it multiplies by the numerator and divides by the denominator. Now we had to pick the lowest common denominator, so that way it's divisible by this one's denominator and all of the denominators. So 4 times 3 is 12. 12 divided by 2 is 6. So it's going to be plus 6n. Okay. Now it's much easier to solve because, well, now we don't have any fractions. Okay. Let's go ahead and subtract 6n to both sides. 11n minus 6n is 5n. So we have 5n plus 8 on the left. And we have a negative 12 on the right. Our next step would be to subtract 8 on both sides of the equation. This would give us 5n equals negative 12 minus 8. Well, these actually kind of add together, don't they? Because they're both negative. Lastly, to get n by itself, we use the division property of equality, dividing by 5 on both sides of the equation. N is negative 4 in this case. Is that what we're looking for? Yeah, it is. Perfect. So we only had to do one equation. That's good. You could do the other ones to check if you like, but I'm pretty confident we did that correctly. Okay. Here's another one with fractions. So we can go and practice that trick we did before. Here it's the same denominators as the other one, right? Half and fourth. So we already know the lowest common denominator is 4. We're going to go ahead and distribute this 4. It gets multiplied with every term in this equation. And this will cancel out our fractions. So that's good. You could even do this. Usually I say move all your variables to one side, right? Here you have W's on both sides. You can go ahead and move them all to one side first if you want, but I think it's going to be easier if we get rid of the fractions first. So let's go ahead and do that. So let's go ahead and multiply everything by 4, distributing the 4 to every single term in this entire equation. So 4 times W gives you 4W. 4 times a half, well, 4 times 1 is 4, divided by 2 is 2. 4 times 1/4, well, 4 times 1 is 4, divided by 4, that's 1W. I could just write W. And then 4 times 2 for our last term, that's going to be plus 8. Okay, you can see it's much easier to work with now that we don't have any fractions. It's a lot less intimidating. Now we can kind of think, okay, we have W's on both sides of the equation. We don't like that. We're going to go ahead and subtract W over here and subtract W over here. When you subtract W, like 4W minus W, well, you can think of this as 1W. So 4W minus 1W is 3W. Okay, don't cancel the W's and say that it's just 3 or something. I see that mistake sometimes. Next, to get rid of this plus 2, I hope you can see we would subtract 2 on both sides of the equation using the subtraction property of equality. We simplify to get 3W equals 6. Then divide by 3 on both sides of the equation, giving us that W equals 2. Okay. All right. Here we're solving 8 minus 3x equals 20. Here I would subtract 8 on both sides of the equation, giving us negative 3x. This cancels, right? Negative 3x equals 12. You can see they did the exact same thing, right? They subtracted 8 on both sides of the equation. Now, what would be my next step? Well, I hope you could see we would divide both sides by negative 3 using the division property of equality. X equals negative 4. So what step did they miss here, or question marks? They need to divide by -3 both sides. Here they show it as multiplying by -1/3. I mean, you could think of it like that, but I don't know why they stated it like that, but whatever. Okay. Next one, number 7. Take a look at this one. This one's a little bit different than what we've seen before. In this one's case, we have a 9x and we have a -4x, but they're both on the same side of the equal sign together. You see that? So they don't actually need to move sides at all because they're already together on the same side. In this case, we would just combine them together into a single term. So 9x minus 4x, again, you just subtract the coefficients. So 9 minus 4. So that's going to give us 5x. We still have a minus 20 over here. And then equals 40 on the right. What do you think my next step would be? Hopefully you're already doing it on your own piece of paper, adding 20 to both sides. Lastly, divide by 5 on both sides of the equation to get x by itself. That tells us that x is 12. Number 8. Well, this one's got decimals in it, and it's got a lot of the variable. You can see there's a 0.4r and a negative 0.7r on the same side of the equation. And then there's a 3r on the right side of the equation. Okay. Well, let's go ahead and we can combine these two over here on the left. So 0.4r minus 0.7r. So that's going to give us negative 0.3r. You have more negatives, so that's why it turns out negative. Also on this left side, we have a negative 0.13. This constant equals, on the right side, we have 3r. We can't combine those over there. We can't combine this 3r and negative 5.74 because one of these has a variable, the other one is a constant. Can't combine those. Okay. So notice there's r's on both sides of the equation. Again, I don't like that. We need to move all our r's together on the same side of the equation. I'm going to go ahead and subtract this 3r here and subtract 3r as well on the other side of the equation. This will result in negative 3.3r on the left. We also have a minus 0.13. On the right side of the equation, we just have this constant, negative 5.74. I hope you can see what the next step would be. In this case, we're going to use the addition property of equality to get rid of this 0.13. Okay. We have negative 3.3r on the left. On the right, we add these together, which actually they kind of subtract, right? Because they're different signs. So that's going to be negative 5.61. Lastly, we're going to divide both sides by negative 3.3 to get r by itself. R is now solved. We just need to divide this. I'm going to go ahead and grab a calculator. Hopefully you have a calculator at home. If not, you could use Google or something. That gives us that r equals 1.7. In this case, it's positive because it's a negative. A negative divided by a negative is always positive. Same thing with a negative times a negative. Multiplying and dividing follow the same negative positive rules. So positive 1.7. Okay, in this one, we want to solve for x. Again, there's a lot of x's all over this equation, right? There's 2x's there's 2x minus 3x on the left, and then there's a 2x plus 5x on the right. So we're going to combine like terms on the left and combine like terms on the right. We always want to combine like terms if we can, before we move stuff around. So 2x minus 3x, that gives us negative 1x on the left. There's still this minus 18. I'll go ahead and add that. On the right side of the equation, we have the negative 18. And we're going to combine the 2x plus 5x, giving us 7x. All right. What do you think we do next? Well, hopefully you notice there's x's on both sides of the equation. We don't like that. So we're going to go ahead and subtract this 7x on the right side to cancel it. We'll have to do the same on the left side to keep it balanced. Negative 1x minus 7x, those actually add together because they're both negative, negative 8x. We still have this negative 18 equals, and then on the right side, we have negative 18 as well. To help us get x by itself, we're going to go ahead and add 18 to get rid of this constant. Add 18 on the right side of the equation as well. Negative 8x equals negative 18 plus 18. Well, those cancel, don't they? Well, if it's canceled, then there's nothing left over here. You just put a 0. Next, like what we've done before, we're going to go ahead and use the division property of equality. Divide by negative 8 both sides. That solves for x. 0 divided by anything is 0. Okay, last one from the practice. Here we have 16 minus 5x equals 1 minus 4x. Here it looks like they maybe subtracted 16 on both sides of the equation. Looks like they did that first. I wouldn't recommend doing that first. I would usually recommend moving all my x's together first, but this is valid. They're allowed to do that. Then they added 4x here and added 4x here. So here they moved the variable second. So what's the justification for step 2? So what did we do to go from step 1 to step 2? Well, we added 4x both sides, right? So that's the addition property of equality. Whenever you're adding to both sides, that's the addition property of equality. Okay. All right. Hopefully you're ready for the mastery test. What I would suggest is go ahead and go through the mastery test and just answer all the questions that you feel confident about. I have 20 questions here, but you're only going to have 5 questions offered to you. You need to get 4 out of 5 correct at least. I'm going to be going over some of the questions in full, and some of the questions I'll just be giving you the first step or so, or maybe just a hint. All right. So you might not have this as your first question. Maybe you do, maybe you don't. But I will go over every question that you have. Okay. Let's see. Here we're solving for x. Okay. What I would do first is combine like terms on the left side. So I've got a 10x plus a 3x together on the left side. That'll make 13x when I combine those. We cannot combine with that negative 4.5 since it's a constant. And we have a 12x minus 1.1. My next step here, I've got x's on both sides of the equation. I generally don't like that. So I'm going to go ahead and subtract 12x on both sides of the equation, giving us 13x minus 12x is 1x. You don't have to put the 1, but here I do. Negative 1.1. Okay, go ahead and see if you could solve it from there. Here is a one where you have to drag these justifications. each tile can be used more than once, but not all tiles will be used. Okay, so you can use a tile multiple times. All right, you can see this one's full of fractions. What I would suggest first is multiplying everything by the lowest common denominator, but they didn't do that as their first step. What they did is, well, let's see. It looks like they subtracted 17.3 on both sides, or 17/3, sorry, on both sides of the equation. So they subtracted 17/3 on both sides of the equation. So whenever you subtract to both sides, that's the subtraction property of equality. Okay. Next, they simplified, or in other words, combined like terms. They use the term simplify. That's a correct way of also saying it. But essentially, they're just combining this 5 and negative 17/3. And they're combining this 17/3 with this negative 17/3. Those cancel, right? So that's why you don't see this 17/3 on the next step. So that's just simplification. We're going to be using this simplification one probably at least another time. Let's see, their next step was they subtracted 1/2 x to both sides of the equation, so they can cancel it here. Okay. So again, when you're subtracting on both sides of the equation, that's the subtraction property of equality. Then they simplified, or in other words, combined like terms. So this simplification gets used again. Okay. Next, they multiplied by both sides of the equation. So what's used there? And then they simplified again. Okay. All right, let's take a look at this one here. So what's the justification for step 2? So we could just look at step 1 and look at how they got to step 2. So we're just going to look at these 2 steps. So here they had 8y minus 40 equals 6y minus 18. You hopefully already know what I would do next. I see that there's y's on both sides of the equation. So I would go ahead and subtract 6y to both sides of the equation. And they did that same thing, didn't they? 8y minus 6y gives us, that's why there's 2y. And then there's no y's on the right side. See that? So which property did they use there? All right. All right, so here where we have a situation with lots of fractions. This one has 1/3 p plus 1/2 p plus 7 equals 7/6 p plus 5 plus 4. Okay, well, I'm going to go ahead and multiply everything by the lowest common denominator, which in this case is 6. I know that 6 is the lowest common denominator because every one of these denominators is divisible by 6. Or I should say divides 6. So 3 divides 6, 2 divides 6, and 6 divides 6. So that's why I'm using this number here. That way, when you distribute it, you could divide it evenly into whole numbers. So when you multiply by this first term, you multiply by the numerator, divide by the denominator. So 6 times 1 is 6. 6 divided by 3 is 2. So this becomes 2p. Oh yes, much nicer, no fraction. 6 times 1/2 p. So again, 6 times 1 is 6. 6 divided by 2 is 3. So that becomes plus 3p. Multiply the 6 times 7. That's 42. Equals 6 times this 7/6p. That just gives you 7p. If you're multiplying by the same thing as the denominator, they just straight up cancel. Plus 6 times 5, which is 30. And 6 times 4, which is 24. Okay, so that would be my first thing I would do always is if I see fractions, I generally don't like fractions. I'm sure you don't either. I multiply everything by lowest common denominator. and that cancels out all your fractions. But just make sure you multiply that number by every single term in the equation. Okay, now let's go ahead and combine like terms over here on the left. We can combine this 2p and 3p, making 5p. We still have this plus 42 constant. On the right side, we can combine this 30 and 24, giving us 7p plus 54. Okay, I'm going to let you try to solve the rest of that on your own. Next one, look at the given equation, negative 3x plus 4 equals 5x minus 6. Roy and Sam start solving the equation as follows. Okay, so we see Roy's work, Sam's work. Okay, so which student's work is correct so far and what property did he use? So let's see. For Roy here, he subtracted 5x. Let's cancel that. Subtracted 5x. That gives negative 8x. I would say Roy looks correct. Let's see what Sam did. Sam got rid of this negative 3x, so he added 3x and then added 3x. He should have got 8x here, but instead he has a 2x. Okay, so Roy is correct. And just tell me which property he used right here. Okay, so it's going to be either A or B. Figure it out. Okay, what is the justification for step 1? Okay, so we have this equation, then we have step 1 here. So what's the difference between these two equations? You can see this left side originally has 8x plus 15, but here the 15 is gone. So you can see they subtracted 15 on both sides of the equation. Okay, so which property is that? All right, justification for step 2. So how did they go from step 1 to step 2? I hope you could see they divided by 2 on both sides of the equation. So which property is that? All right, here this one's going to be a bit of solving involved. Select the correct answer. Consider the following equation. We have negative 16p plus 37 equals 49 minus 21p. Select the equation that has the same solution as the given equation. So first, let's find the solution for this equation. Here I've got p's on both sides of the equal sign. There's negative 16p on the left and a negative 21p on the right. Whenever I see that, I like to move all my variable to the same side of the equation. So I'm going to add 21p to both sides. Negative 16p plus 21p is 5p. So we have 5p plus 37 on the left, and just the constant 49 on the right. To help us get p by itself, we're going to go ahead and subtract 37 on both sides of the equation, giving us 5p equals, and then we have 49 minus 37, which is 12. Go ahead and divide by 5 on both sides of the equation to help us finish solving for p. So we're going to divide by 5. Divide by 5 gives us that p equals, and if you want it as a fraction, you could leave it as 12 over 5. If you want it as a decimal, you can just divide that using calculator, but that should give you 2.4. Okay, this fraction and this decimal are the same thing. So I want you to go ahead and try solving these and find out which one gives you that same solution. P equals 2.4 or 12 over 5. Okay, what is the justification for step 3? So if we look at from step 2 to step 3, here you could see they added 5 to both sides of the equation, canceling out this 5. So when we add to both sides of the equation, which property is that? What's the justification for step 1? So here they went from here to here. It looks like all they did was combine the 5 and this 9. So which property or which justification is that? For this one, let's go ahead and solve for x. So taking a look at this, we have this 0.5x and this 0.9x together on the left side. Whenever I see that, I want to combine those together. Okay, so always combine like terms if you can. Don't combine across the equal sign. We're going to have to use, properties of equality to do that. So 0.5x plus 0.9x, they're on the same side of the equal sign. So we're going to combine those. That's 1.4x. We also have a plus 4 over there on the left side. On the right side, we have an x plus 5. Notice here we have x's on both sides of the equation. We generally don't like that, so we're going to go ahead and subtract x from both sides of the equation. You could think of this as 1x, if that helps you. 1.4x minus 1x is 0.4x. We also have a plus 4. On the right side, we have a 5. Okay. Go ahead and see if you could finish solving it from there. What is the justification for step 1 in this process? So how did they go from the beginning to step 1? Well, I hope you can see they added 8 to both sides of the equation. So to cancel this, right? That gives you the 15x over here on the left. And 21, 13 plus 8 is 21. So see if you can figure out which property that is to justify that step. Here we're trying to justify step 2. So we're going from here to here. Okay. What do you suppose they did here? Well, I hope you can see they subtracted 1/2 to both sides of this equation. So which property is that? Here we're trying to find the solution for t. So let's go ahead and solve for t. One thing we could do here is we can multiply every term in this equation by the lowest common denominator. Here we have thirds and fifths. So we have a 3 and a 5 in these denominators. So what would be the lowest common denominator in this case? In other words, what number is a multiple of 3 and a multiple of 5? Well, that's 15 in this case. So we're going to go ahead and distribute this 15 to each term in this equation. Remember, to do that, you multiply by the numerator, then divide by the denominator. So 15 times 2, then divide by 3. So 15 times 2 is 30. 30 divided by 3 is 10. So 10t. 15 times 1 is 15. 15 divided by 5 is 3. That negative also sticks along. So negative 3t equals, don't forget, 15 also multiplies with this 2 here. Because we're multiplied one side by 15, we have to multiply the other side by 15 as well. That's the multiplication property of equality. Okay. Next, let's go ahead and combine like terms. These two t terms are together on the same side. So we just subtract the coefficients. 10 minus 3 is 7. So this is 7t. Okay. Go ahead and solve it from there, but I do want to point out one little detail that will make your life a little bit easier. Notice that when I write the letter T, I give it a little curl on the bottom, okay? Because if you don't do that little curl, a lot of times you'll confuse the T with a plus sign, right? And if you ever confuse that, which I used to do all the time, if you ever confuse that, could mess you up a lot. So I give my little T's a little curl, so I never confuse them with a plus sign. Okay. I would suggest doing that in general. Okay. What is the justification for step 4? So we're going from step 3 to step 4. Here it looks like they multiplied by the reciprocal. So they multiplied by 3/8 on both sides of the equation. So which property allows you to do that? Here we're solving for x. So one thing I notice here is that there's 2x and this negative 8x on the same side of the equation. So when I see anything I combine together on the same side of the equation, I want to combine that first. So my left side doesn't change, nothing to combine. I can't combine this 9 and negative 10x, so I'll just rewrite it as is. On the right side, though, I can combine this 2x minus 8x. That gives me negative 6x. Here, they subtract each other because they're different signs. I have more negatives, so that's why it's negative. I also have this +1 constant. Well, like we've done before, whenever I see x's on both sides of the equation, I don't like that. So I'm going to go ahead and add 6x to both sides of the equation. That's going to give me 9 minus 4x equals, these cancel over here, leaving me with just 1. Next, I would subtract 9 on both sides of the equation, giving me negative 4x equals 1 minus 9 is negative 8. See if you could solve it from there. Okay, here's another one. Here we have a negative 11x and positive 6x on the same side of the equation. So I can go ahead and combine those like terms. That'll give me negative 5x. They subtract each other because they're different signs. But I keep this sign of the negative because there's more negative. Here we have equals 0. Go ahead and see if you can solve it from there. Okay, this next equation has quite a bit of combining like terms. On the left side, I can combine these two constants. So I'm going to go ahead and do that. So that's going to be 4x. And then we have this negative 3 plus 5. Well, that combines to positive 2. We have more positives in this case. On the right side of the equation, this 2x and negative 8x, those combine as well, giving me negative 6x. We also have a +7 constant. For our next step, we have x's on both sides of the equation. I don't like that, so I'm going to go ahead and add 6x here on the right, and then add 6x on the left to keep it equal, giving me 10x plus 2 equals 7, and go ahead and see if you could solve it from there. Here we have some fractions involved in our equation. So like we've done before, I'm going to go ahead and multiply by the lowest common denominator. In this case, both of them have a denominator of 3, so I can just multiply by 3. This makes it easier, but remember, we multiply this by every single term in the equation. Here it just cancels with the denominator, giving us 5x plus, not 4, 12. Because remember, that multiplies with the 3 there. And then 3 multiplies with this, giving us 2x. Okay. Here I've got x's on both sides of the equation. So I'm going to go ahead and subtract 2x on both sides. That way I only have x's on the left. Go ahead and see if you could solve it from there. Last one. Here, once again, I see that there are x's on both sides of the equation. So I'm going to go ahead and add x to both sides. This cancels on the right. And adding x here gives us 29 plus 15x plus another x is 16x. We still have a negative 3 on the right. My next step would be to subtract 29 both sides of the equation. Canceling this out, giving us 16x equals, and this would be negative 32. You can go ahead and solve it from there. Okay, so I went over all the questions that you might have gotten on the mastery test and everything you've done on the practice and tutorial. Hope that all made sense. If you have, if you'd like to say thank you, then you could always subscribe or just share this with someone else who might find it useful. Well, with that, thanks for watching, and I'll see you guys next time.